Alright, so in this video I'm going to introduce you to the idea of the two types of sequences we're going to look at this year. So you should have already watched the basic sequence intro and the how to build a recursive pieces with the subscripts video. So before we get into writing the recursive and the explicit form of formulas, we need to know what these sequences are, because that's going to determine how we write these formulas. So you have to know the difference between arithmetic and geometric. So arithmetic sequences are sequences where you add or subtract to get from one term to the next, and you have to add or subtract the same number each time. That's the key. So there might be a sequence where you're adding 1, then adding 2, then adding 3. Well, that's not going to be an arithmetic sequence just because you're adding. It has to be adding the same number. So you want a sequence, for instance, that's like add 1, add 1, add 1 all the way through. Alright, so geometric, on the other hand, is multiplying or dividing to get from one term to the next. And again, it's got to be the same number. So you might have a sequence where you're multiplying by 2, then multiplying by 3, then multiplying by 4. But that's not going to be geometric, even though it's multiplication. So don't fall into the trap. It's got to be multiplying by the same number or dividing by the same number. So let's check it out. And I like drawing arrows, and I suggest you do too, because it just gives you a visual of what we're talking about. So when I say, how do I get from 2 to 4? Well, there's some ideas hopefully floating in your head. Well, you could add 2, or maybe you could multiply by 2. So maybe we need to jump over here and help determine which one of those is the right one. So if I say I'm multiplying by 2 to get from 2 to 4, it, remember, has to work the same on the rest of the pattern. So if I do 4 times 2, that's not going to give me 6. So this must be the plus 2 pattern. So I'm plus 2 here, plus 2, plus 2. That works. So this would be an arithmetic sequence because you're adding the same number every single time. Alright? This one, draw your arrows again to determine what's happening. You could say 2 plus 2 again, but then you go try 4 plus 2, that's not going to be 6. So this needs to be times 2, because 4 times 2 is 8, and 8 times 2 is 16. So if you're multiplying the same number every time, this is your geometric. Alright, now here, 1 to 4, you can either add 3 or multiply by 4. Well, if you add 3, let's check it out, then 4 plus 3 is not going to be 9. That's not going to be it. Alright, so what the other option was times 4. Well, let's try that. If you multiply by 4 here, check it over here, that's not going to work either. So this is neither arithmetic nor geometric. So there is a pattern here, and I'll go ahead and point it out to you. To get these special numbers, I'll tell you the next one's 25. Maybe that's a hint. These are all special types of numbers called perfect squares. So this one is obtained by doing 1 squared. This one is 2 squared. This is 3 squared, 4 squared, 5 squared, and so on. Alright, so there is a pattern, but it's not arithmetic or geometric. So this one, maybe we could say that's subtract by 50. But then if we check it over here, that's not going to happen. So the other thing we can think of is maybe divide by 2, because 100 divided by 2 is 50. Well, if we do that over here, that does work. 50 divided by 2 is 25, and then 25 divided by 2 is 25 divided by 2. It's just going to be a fraction that we could turn into a decimal. So, go back real quick. I forgot to write what this is. You're dividing each time by the same number, so this is geometric. Alright, so here's your practice. Pause the video for a minute, write these down on your notes or scratch paper somewhere, and all I need you to determine is these are geometric, arithmetic, or neither. Alright, and then come back and check your answers. Alright, here's your answers. The first one is geometric. You're multiplying by 3 to get to each term every time. The second one's arithmetic. You're adding 5 each time. The third one, you could think of this as divide by 4, but I've made a note here. When we start writing recursive equations, they're not going to write it as divide 4. They're going to always refer to these as multiplication. So you need to think divide by 4 is the same thing as times by 1 over 4. Alright, so times by a fourth, cutting it by fourths every time. And then this last one is a neither. And I'm not going to tell you what sequence this is. It does have a pattern to it. But I want to see if any of you can come to me tomorrow and give me the pattern, and I'll know you have the pattern if you can give me the next few numbers in this sequence. So take a look at it challenge you to think beyond what you think you can do. There is a pattern here. So think about it, and until next time, keep practicing.